Hi everyone, I'm Nicolas Rosado, a passionate software engineer, and today I'm really excited to start this new episode of Craftcode podcast about tech trends and demystification of IT principles. And today we'll talk about TDD, test-driven development. We'll see what is TDD, how TDD can impact and reduce drastically your daily stress, and how refactoring techniques can be a game changer in legacy code. And we'll see if we can apply TDD in a legacy project. So today we are with Nicolas Carlo. Hi, Nicolas.
Hi, Nicolas.
Okay. Maybe you can start by the beginning. Could you tell us who you are?
Yes, of course. So my name is Nicolas. I am a freelance full-stack web developer. So I work mostly with, nowadays it's TypeScript, front-end and back-end for clients. I live and work from Montreal, Canada. And I have that specialization in legacy code bases, not necessarily JavaScript, by the way, but it's been a bunch of years that I've dug into legacy code bases, refactoring, and everything that goes around it, testing, but not necessarily TDD, but we can talk about TDD in legacy code. Yeah. That's interesting.
And I know that you like legacy code, yeah. So
yeah, it's we can talk about it. It's something for most developers it's painful, and yet if you're working, unless you're working with a greenfield startup, you will have to face it. So it's I found it was interesting to dig into it, and once you start digging into a topic, you start liking it more and more.
Yeah, because the legacy code is everywhere, yeah, in most enterprise. So just before start the podcast, I need to tell a little disclaimer. We are here not to tell that you must apply TDD. TDD is a technique, but it depends on your knowledge, the context of your project, and the learning curve. And we are here to focus or to highlight on the benefits of TDD. Yeah, so we need to see how we can use TDD, but we'll see if you can apply it in your project. Okay, so we can start by the definition of TDD. Maybe Nicolas, could you tell us a little definition?
Yes, I'm gonna go with my explanation of TDD. So test-driven development, like a lot of DD thing, like driven development, it's a way to write code, to program and create software. In this case, driven by test, which of course relates to testing. But TDD is not just about testing. It's about it's how you're gonna write new code, how you're gonna design your software. Practitioners of TDD will refer to it as a design technique also, and we can explain why. But how it looks like, and people may be familiar with that already. We usually represent this as a loop, like a cycle with 3 phases that you go through. You start writing a test first. So you write the test before you write the code. You see that test fail. So we'd say it's the red phase because it's the test is failing first. So you write a failing test. Only one, simple one, proving that the software does not do what you want it to do. The second phase, once you have that failing test, you write the minimal implementation to make that test pass.
And it's really important. The minimum.
The minimum. It's also where things is hard, and it depends, and it takes practice. But you just want to go to be in a place where your test is green, and so it means okay, the software is doing what it needs to do, even if it's dirty. You want to get that there fast.
Most of the time, the first time it's dirty.
The first time it's dirty, and then it depends if you really know where you're going. If you don't, it's flexible. Once you are here, so you have working software and a test that is also working, so it's green. You have the third phase, which is refactoring, which is where you take a step back and think about, okay, I took some shortcuts, maybe I should rearrange the code a little bit to make the next phase easier to go, because you don't want to be in a red phase and be like, oh, but the code doesn't look like I need to refactor the code to easily implement my feature. You don't refactor on the red phase, you refactor once you're green. So the refactoring phase usually happens at the third step. And once you're done, once you're happy, you move back to the red phase and you loop like that until you're done. So that's the basic definition I would give of TDD.
So just to have additional information, the misunderstanding of TDD is that we think that it's a test technique, but it's a technique to drive the development. So the consequences is to have some tests, because it's a test first approach inherently or intrinsically. So we have a code already covered by the test, because we start by the test. And just to highlight the phase one, we need to start by missing or expected behavior. So we need to start by this miss behavior or expected behavior. And after, like you have said, we need to try to pass the first test as soon as possible with the minimum code. And in the refactor step, I think we can apply some principle like Yanni, you ain't gonna need it principle, and avoid premature optimization. It's really important. And by having this feedback loop, by again and again try these steps, by adding more behavior, we are able to, by triangulation, have a test. As your test gets more specific, your code gets more generic. And it's in this refactor loop that we can have this. So I think the word, it's baby step. You need to advance with baby step. So it's really great to be driven by this test to implement the code. So maybe you can tell us, it's a little definition of TDD, but how TDD can reduce or impact your daily stress. How these techniques, by apply this loop, reduce your daily stress.
Yes, it's a very interesting question, a very interesting angle. There are many things we could do talk about TDD, because some people have tried it, they don't like it, something that it's actually very difficult to apply in some situations, etc. We could cover these, but for the angle of stress, if you manage to write some part of your software and you follow the TDD approach, you get into that rapid feedback loop, where usually, because it's a test, it will force you to do test first. Test coverage will be a side effect of it, so you usually don't look for test coverage, but you have a good one as a result. And just that, having software that is covered by test, just that reduces your stress level. So you can have that even without TDD, but knowing that you can make a change, and if you introduce a regression, you will know it right away, makes it easier for you to... You are more confident in the changes you are making, and you're wasting less time, provided the test, when they fail, they are helpful, which is also why the first phase, that's why we write the test first and we see it fail, because it's also a moment where we can improve. You know, when you see the test fail, you want to see it fail for a good reason. So maybe you want to improve the message here, or the assertion, or sometimes people don't think about that, but it's the moment where you look at critically at the error and you're like, okay, imagine I'm later and I introduce a regression, I got this test error. Do I understand what is going wrong? What I should look for? And TDD, it's not the only solution to have that, but it helps you do that. It's like pushing
but
you to
it's
do
a
that.
consequence of the test first approach, but not TDD,
Yes.
because TDD, like you say, it's about thinking about the expected behavior. Because I think we will talk it later, but in legacy code, most of the time we are in a test last approach, and here in TDD, inherently we are in test first approach. The consequence is to have a good coverage, and we start by the test. But TDD is more than that, because it's about thinking about the design and in refactor step, but thinking about the behavior or the next behavior, and it's why TDD can reduce your daily stress. It's more than the test first approach. Yeah.
It can reduce your. You're totally right. And another example I like to give. Many people are not familiar with that, but there is also the README-driven development
Really?
concept that
Okay.
exists. Yeah, sometimes when you, I applied it recently when I was crafting a module with and I wanted to clarify, think about the API I want to expose to the users of that module, which were another team. You start from writing the documentation of the ideal API you would like to use. Like,
Yeah.
okay, if you were to imagine an SDK and what it would look like to be used, and you start writing the documentation, the thing does not exist yet, but you write the documentation. And so that README driven development, as a consequence, you have the documentation ready, but it forces you to think about what you want to achieve first. And TDD is the same. Difference is you
But
don't
in
write
baby step. Yeah.
yeah, you don't write the, oh, you can also do readme in baby steps, but you don't write the documentation that you don't execute. Instead, you write an executable code, which is the test,
Yeah.
that proves the software is not yet doing that, and that you will progressively, it's like you're writing, okay, what is the next thing you want to do, and not just on a piece of paper, but in code. So that's where it takes a bit of practice. It's better if you're familiar with writing tests and expressing yourself in test. But you really take that approach to help you think about what you want to build, can reduce your stress. I don't know about the stress, but certainly your workload, because it happened to me a few times when by using a TDD approach, I ended up doing fewer code, implementing fewer things in the end, because that's what I needed the software to do, and that's all. And as long as I have an implementation that worked with that, I'm done. So I'm done actually faster than if I was trying to implement something very generic from the implementation, try to cover every possible theoretical scenario, and then eventually check, okay, can
Yes.
now
You think about just a little next step and not the entire
the
work.
baby steps.
And it's how TDD can drive you and help you to not think about the entire solution. And
You reduce the scope, and
you're,
again,
you're
well, it takes practice, but that thing of you have all of this feature to implement, you can brain dump all of your ideas on a piece of paper, for instance, and then you're like, okay, one thing, I'm gonna take one thing, and this one, and we haven't talked about that yet, but sometimes, especially at the beginning, you're like, okay, I want that behavior that is very high level. And then you realize to implement that behavior, I can actually have subtasks. I can chunk it into smaller steps. And so you have the concept of a double loop TDD, where you start with a high level failing
yes,
test.
it's a TDD, sorry, coupled to for the sub step TDD. Yeah, it's
In my experience, you naturally get to there because in practice, when you apply it to like not just a coding exercise, but something you're not yet super, what happens in reality is that you work on a feature and you don't exactly know everything you will need to do, but you have an idea of rough things you need to do. So you take the first one, you try to express yourself, write a high level test, and then you realize, okay, but the first thing I need to do is this, at least this scenario, smaller thing. So you skip that test for the moment, and now you write a smaller test to describe just that, and you do your TDD loop, and you keep going until you finally, all of these will make the high level test pass or easy to write.
And is it how you use TDD by maybe specification by example, and for each sub-step you use TDD to develop it? Or
it happens frequently. It's more of a, I think if you practice it seriously, like on actual code and features, you will naturally get to that point where you want to practice TDD, and what happens is you're on the red phase and you realize that it's going to take a while to implement it because there are many sub things you can do. And so the point of ATDD is to, okay, break it down and do smaller loops of closer to unit test. And that's an interesting point. Like the A in ATDD is for acceptance, because usually, okay, when you write test at this point at a high level, you want to attack your software at a high level. So you don't start from the small functions and the collaboration, but you are like, okay, I want to write an acceptance test. And then there are many
close to the business? The
closer
A
to the business,
provide by the business, yeah? Okay.
Yes, by the business.
So maybe the link, it's a link between TDD and the business who pass through the acceptance test, yeah.
The whole idea behind all of that is you start from the problem you want to solve with software, and you prove the software doesn't do what you want it to do. So it's easier to do when you're fluent with expressing yourself with test. But once you are familiar with expressing yourself with test, writing the test without the code is actually reduces the stress, I find, because you can just imagine you have everything works perfectly as you imagine.
Yes, you start by the assertion, yeah.
Exactly.
You see the result before the code, yeah.
From the consumer part, okay, imagine everything is working. What would it look like? And it's maybe you could imagine you have a different hat. You are like, okay, now I'm consuming that code that doesn't exist, but imagine it would exist. I would love to use it like that to solve my problem. Then the test tells you it does not work. And now you change hat and you're like, okay, now I'm going to implement that. Okay, this is the API you have crafted as a consumer, the one you want to have. Let me make it work. And then when you do that, you may realize, oh, actually, I need that first. And then that's where you have that. It's usually TDD is presented as, on simple exercises, on pure code, pure functions, simple code, algorithm. So it looks easy. And then people are like, but I cannot use that at work because I rarely am working on the simple algorithm. And this is where the
yes, but
gap
we need to go in depth in this point, because I think TDD is we need to have a feedback loop really quickly. So maybe we have some prerequisites, because we need to have a testable architecture. And is it the TDD that drives the testable architecture, or we need to have a testable architecture in prerequisites? So what is your thought about that?
No, it's more of a consequence. If you do TDD, you will do test first. And if you do test first, as a consequence, the code you write is testable. It is tested, so it is testable.
Yes, but it can be a benefit. So I need to highlight to a podcast listener that if you start to practice TDD, naturally you will drive to a testable architecture, because
And it will drive a lot of questions. It will raise a lot of questions you will need to solve. So usually when TDD doesn't come so low because it forces you to think about testable architecture. So how do you make code testable? The question underlying is what makes code hard to test? And there are many things, but a common denominator in my experience is things that are not under your control, but you need to use because you're writing software not just to do some, it's not pure function. You're connecting to third-party APIs, to the UI, or exposing an API. Like you are connecting to the outside world that you need to use and to talk to.
You talk about dependency that are not stable,
not stable, or at least you do not control them.
Flaky,
for example. For example, you need to implement something that uses a payment system, and you will use someone else's code to do the payments, and so you use their library or their API that you need to talk to and to consume. This, you don't have control over it. Like they give it to you and you use it, which is fine. But usually these are the points where it becomes hard in the test, because in the test, what you want is to simulate different scenarios. But this part, you're not in charge. So what do you do? And then to make it testable, you need to find a balance between you want to test a real thing, but you also want to be able to simulate scenarios and see how your software, how your logic is handling this in collaboration with.
You shift on the because you have Nicolas have a first aid toolkit for developers for tackle legacy code, and you shift on the rule 9 or 10, I think. It separates the core from the infrastructure, and what you're talking about is that we need to identify what is infrastructure and what is our domain.
Yes, this domain and infrastructure I took from DDD because these are common words. I found that infrastructure as a name can be confusing, because if you're not familiar with DDD, it sounds like DevOps or something like that. It's not. It's more. I like to call it IO. But in general, think about the things that are outside of your code that you need to use. And yes, usually these are the things you need to use but are hard to test. So a testable architecture is a way to organize your code so you can cover most of your logic, the meat of your application, with a fast and reliable test. And then have some tests that will verify that your integration with the others matches what you expect.
But by nature, is TDD respect first acronym? First is to do we apply? Can we apply TDD without an architecture like the power and adapter architecture, or is it possible or not?
Oh, but as long as you write the test first, it is possible. It will just be easier to test your software if you have an architecture that makes it easy for you to have fast and reliable tests. But you could apply to anything. And the reverse is true also. You can end up with testable code even if you didn't write the test first, but maybe because you had that in mind when you were writing the code. Or, and we'll get to that, but you have existing code, it's not tested, and you need to refactor it so you can test it. So refactoring legacy code, which is a paradox, because usually we say, and we said it in TDD, it's better to refactor when you have test, but with existing code, you sometimes have to refactor so you can write some test. So
it's the third question. It's how we can use refactoring techniques in legacy code. But in this part, could we apply TDD, because TDD have a test first paradigm or approach. So in the legacy, we are in test last if the the code is not covered. So can we apply TDD, or how we can apply TDD in this kind of a project? Because maybe we need to have some prerequisites, like have a testable architecture before. So I'm really interested in how we can start TDD in a legacy project. And I think in your first ed toolkit, I see that we have hotspot analysis to see which code we can focus on it to start in this way. But also we need to separate the core and the infrastructure. And I see another point really interesting is the approval testing. And my point is, do we start by approval testing or techniques like that before start to apply TDD?
A lot of interesting questions.
Yeah.
So I'm gonna try to start from. You have
Because
existing code.
I need some pragmatic solution for a podcast listener. So I have a legacy code. How I can apply TDD? Should I need to have some prerequisite?
So, yes, yeah, you have code and you want to take a TDD approach. In theory, nothing is blocking you. Like the TDD approach is, okay, you need to touch this code for a reason. Usually you need to fix a bug or change the behavior of the code.
Yeah.
TDD is telling you, okay, but before you do the change, first write a test that proves the bug exists or the feature the behavior is not implemented yet. So you can do that. Usually the problem you will have is you try to put the existing code under test and then you struggle because there are things in the middle that it will, for example, imagine you have that payment system thing. If you run that code in a test, and if you run the code in the test, it will actually make a query to that third party that I even had to deal with the API where they didn't have a sandbox environment. So if I was actually making a query, I was in production. So now I need to think about how can I put the code under a test to write the failing test I want to write. And so that's where usually...
Yes, we need to maybe start to refactor before.
Yes, so before you can really use TDD, you need to put your existing code under test. And to do that, you may need to refactor it first. But ideally, you want to refactor once you have test in place. So that's the paradox. There are two things. Approval testing you mentioned. Approval testing, people know that under different names. It had different names, but the concept is the same. I'm going to try to explain it simply. The idea is to capture the existing behavior of the code. So you take that existing code and you assume whatever it does, it's correct, actually bugs included, which may be necessary because maybe you're very familiar with the code, but very likely you're not necessarily very familiar with the code. So you don't know what the code is really doing.
Okay.
Try to understand, but it does something. You don't want to break anything. You need to change it, but you're not super familiar with everything. It's complex, not documented.
You're afraid of just...
People who wrote that code are gone for a long time. They're not here anymore. Like you're in this situation. Approval testing is what people may actually intuitively start doing, which is try to run the code in a test and capture whatever it does, even if you don't understand what it does. So
you capture the output of the method.
It's more or less complicated depending on the number of side effects you have. But the idea is to capture some sort of output. So when you run again under the same conditions, you can compare the output to the previous one. And if they are different, you raise a warning. You are saying, hey, something has changed. And you're asking the developer for approval. Is this change expected or did you introduce a regression?
But how you just to focus on this part for the input data set, how you choose the data because it can be everything.
It depends on what you're testing. It's also a bit more complex because you have the explicit data you provide, the inputs, but there is also the context. For example, if in your code there are some queries to the database, you may need to set up some data before you run the code to be in a specific context. It starts very messy, and the goal is you capture the existing behavior of the software in an automated test.
Yeah.
So you can refactor it, so you don't change the behavior, and your test is just here to tell you, yes, it still works like before. To simplify the input outputs, in general, you want to extract pure logic from the rest. So you have something you can test more easily because you can provide explicitly the inputs and you can check the output.
But for a specific data set, yeah.
For a specific, and what also something that is you need to experience it. But when you're doing that, you started from a code you don't really understand, and while you're actively working with it to refactor it, even if you don't keep the refactoring, you will learn a lot of things about what it does, and that exercise is usually valuable.
But how you know how many snapshots you catch from the input data? Maybe do you use property-based testing? I don't know.
You can, you can. You don't have to. It's a combination. You will learn things. Usually you can use. That's a very interesting usage of test coverage.
Okay.
If you write one approval test and then you check the test coverage, you check the source code, you will see the parts that are not covered. So if you need to touch this part, you know that there are more scenarios you need to write.
Okay, it's really pragmatic. Okay, you thanks to the coverage, you see if you need to have more snapshot from approval testing and more scenarios. Sorry.
Or eventually, if you cannot find any more, maybe it's dead code. That's also something that can happen. You realize this code can never be reached, but there is no silver bullet. You need to practice it. You can use approval testing. By the way, I said there was many names. Like it was called Golden Master.
Golden Master.
Characterization test. Also, Michael Feathers called that characterization test. In front end, they love calling it snapshot test. It's actually the same, but all of that is the same mindset behind. You have existing code that does what it needs to do. You want to capture it in a snapshot.
To create your first test in the legacy context. So to be more confident about refactor.
Yes, and I prefer use. So I went with approval testing as the name for two reasons. The first one is that's actually today, if you look for approval testing, you will find a lot of resources, including libraries in many different languages that will save you a lot of boilerplate for writing these snapshots. And the second one is another thing that is very similar is a visual regression test. So you have something that produces UI, and you decide, I want that UI to stay the same. So I'm gonna take a snapshot of that, and next time I run the test, I will take a snapshot of the same thing and compare. If they are the same, the test will be green. If they're different, and that's where it's a bit different, the test should not fail. It should ask for a human review, if you will, because there are two options. Either the change was expected, and this is what it should look like now, and so you are approving the new snapshot, or it's not. And in this case, it's the human who can tell, yes, there is the difference is a regression or not, because maybe and two gotchas are, the first one is you have noise. I use the example of images, but it's very true with data where you have dates, for instance. It could be the current timestamp. And so, of course,
Yeah.
the next time you run the test, the date will be
Yeah,
different.
you talk about the deterministic test or not?
Exactly,
Yeah.
exactly. So, and that's where approval testing library will give you tools to scrub. So you will just make
Okay.
you will remove the noise, the non-deterministic part.
It can be it permits to identify if the test contain the code contain some not determinist dependencies. Yeah. Okay. I
And
understand.
help you make your output deterministic. So like it's a date, but you don't care exactly which timestamp, and so when you run it again later, you can compare. And so that's the noise. The second gotcha is how people mostly use snapshot tests. I'm looking at Jest in particular. So they write code and then they're like, oh, but I can just take a snapshot of it and then use that as test. And it's not great because what happens is when their tests fail, they cannot tell if the new change is legit or not. So what they do is they approve whatever it is, and so the test is not helpful. Because this test, the only thing that tell you is not what the code is supposed to do. It's not a specification you can read. It's just telling you whatever the code is doing today, it should keep doing it.
Okay.
And you could... Emily Bash has an example where she uses approval test with TDD, because if you have a good snapshot, like something you can read as a human, and because it's formatted in a way that makes sense to you, but it's just a text snapshot. Like there is a kata with receipts, like a ticket receipt. And the output of the code is formatted as a receipt. So you can tell where is the error in a visual way, and it's very convenient. You could create your snapshot first of your expected scenario, change it manually, like craft your snapshot manually, run the test, it will tell you it doesn't work like that, and then make the approval test work. But it's very niche.
Yes, but you said to talk about the date, for example, if you not start from scratch and try to use TDD, we need to extract non-deterministic dependencies. So we need to have a prerequisite, and not in legacy code. Before we need to identify what is not deterministic. Sorry, and we need to work on it before.
Yes, non-deterministic will be connected to things that are not under your control. In this case, the date is the date of the system. It's outside of your system. Now, depending on your languages and tooling you're using, there may be convenient things to create a deterministic environment for the time, for instance.
But my point is, should we apply the dependency version, about the idea of solid, should we apply it before TDD? Because it's test last,
Let me go back to the original question, actually. So TDD on legacy code, we went to approval testing. So approval testing is you have code, you want to refactor it, but you don't want to refactor without tests. Approval test is the fastest way to capture what the code is doing. So you can do the refactoring. Refactoring is really, I change the structure of the code, but I don't change the behavior. The code is coupled today. You have non-deterministic things inside in the middle that you cannot inject, really. And so you want to change that code to still do the same thing, but you want to push away the non-deterministic part to the top or the bottom. So you have a good chunk that is purely deterministic. It's pure logic, interesting logic. So you're refactoring your code like that, and you lean on the approval test. So at this point, you're not fixing your bug or implementing a new feature. You're rearranging the code, so it's easier for you to change it, to evolve it.
So you try to reduce accidental complexity, So in a refactor.
So the first was you write a approval test to capture existing behavior. Then you refactor and you have your test, your safety net, so you know if you make a mistake, because refactoring that code can be difficult.
Yeah.
You maybe will make a mistake. So you refactor until you're happy. You don't have to refactor everything also, but until you're happy that now you can take that code, write a failing test to show that it doesn't do what you want. So with the intention, compared to the approval testing was just saying whatever it does, it will still do it. Now you're saying, okay, when we're in this situation, then I do that, I should have this, given when then. So you write your test first, and then you make it pass, and then you refactor, and you're back in TDD. That's the most common way would be that. Another way, just to mention it, Michael Feathers in Working Effectively with Legacy Code presents different techniques, concrete techniques.
Yeah.
You may not have that. Maybe you need to fix a bug very quickly, and you don't have time to refactor the whole thing, etc. Instead of just trying to manually test it and cross fingers you didn't break something, you can also do. There are two techniques: the wrap and the sprout. But the idea is the same: is you write your new code somewhere else. So you start from greenfield. You create a new function from scratch, and it does this, and that. And then you inject it with minimal changes in the existing code. So that's a way to create a bubble of greenfield.
Yes, you create a safe zone. Yeah, and
where you can do TDD and everything.
But what you describe, it's a safe zone, and it's how we can reduce your daily stress. Because, like you said, you not just make a change and hope that it's work. You're in you have a tech debt under control. Yeah, so it's really interesting how this approach can impact and reduce the stress on your daily task, because you work on a safe zone and in a bubble. Yeah,
that's also how we introduce domain-driven design to an existing code base. Like people who want to do DDD, so first they should start with start talking the same language with the business and be mindful of that. That's a good first part. But technically, they want to apply DDD in their code base, but they are working with an existing code base, and they are wondering how can we do that. And the approach is technically to consider the existing code as a distinct context. It's your big ball of mud or whatever, and then start fresh with your new context, and progressively you will have to interact.
Yeah, you move some
and you progressively
object in your domain.
Things, the object, the domain, also maybe the database. So you create the new thing and you interact with the old one. You still ship everything at once. You don't try to do a big bang refactor. As you go, you refactor the thing, but you create that safe space where you can apply TDD and all that, where you are in control of what you're building, and you have test documentation. It speaks the language of the business. It's much easier to maintain, also because while you're doing that, you are learning versus the code you had to deal with. I imagine you're in a situation where you don't really understand everything it does, which is also why you should not just say we're going to rewrite the whole thing.
Yes, but we try to reduce the entropy of the system, but by covers little step, and it's like the compound interest, at the end, by refactor little step, the whole domain will be moved to your domain-driven design. Or
yeah, and usually this kind of projects take a while. That I need to give a warning about that approach. It should not be the initiative of one or two developers. It should really be the team initiative, because I have worked on code bases where a payment system, so there was a V1 that was built a long time ago. And then the team, some of them decided they will do a V2 with new features, more robust, better, because they learned since. And so they went for a rewrite of the V1 and replace it with the V2. But that project took a while, and while they're doing that, they still need to implement new things or fix bugs on the V1. So it's a moving target.
Yeah.
And eventually that project lasted for 2 years with reorganization. So everyone involved eventually left the company.
Okay.
At least the ones who were involved in the project. And so the people, that's where I arrived eventually into that team. We had a V1 that was used in prod. That was a V2 that was not used by clients but used internally, that could do less than the V1 but would do it better, but it was incomplete and it had diverged. And they were talking because of that painful, every new feature we're like, okay, we need to write it in V1 and in V2, so double the
Yes.
cost of everything. People were talking about scrapping all that, doing a V3. So the pitfall of thinking I'm gonna do a greenfield bubble, safe bubble, and do things better here. This takes a while. It needs to be a commitment of everyone, so yeah, the V3, I said stop. Let's not do that. Hopefully, I was the tech lead, and the strategy was more what I think should have been at the beginning. Not have a V2 that is not being used and built in parallel like a rewrite. It won't work. Keep working on the V1 that is used in prod and have a plan to bring it to a point where it looks like the V2 progressively, and ship that. So you will rewrite, but in small chunks.
Yes, but
And
what you describe is TDD or test first refactoring techniques is the base of other techniques like continuous deployment, and you need not to have a branch that you merge in a 1 month, for example. You need to merge continuously on the trunk, or maybe a little branch, one with a little life. But it's important to not work in isolation. Yeah, it's what you described.
yeah, probably what you said is the core of this podcast is everything like TDD and all the techniques we mentioned, and even more we haven't mentioned because you briefly said trunk. So like there is trunk
Yeah.
based development, etc. All of these core of techniques, they come from the idea of you want to reduce the feedback loop to reduce the risk of changing code. And that's the goal. So the goal is to, instead of doing things for a while and then eventually ship it and then learn if you're right or wrong, you try to ship as fast as you can changes to see if you're going in the right direction.
Continuous way.
In a continuous way. And TDD is that you do baby step because you don't know all of the things you will need to implement. You're working on a feature, there will be unknowns, there will be surprises. You will use TDD to start step by step. You're building small feature by small feature, one test at a time, and it forces you to do that instead of trying to jump into it. And that is true for code, that is true for business also. The only difficult part of that is it will be messy because you will, to go from state A to state B, you will spend some time in transition, and that transition can be actually very messy. You need not to stop in the middle and keep going well, you will adjust the direction, but keep going. Have the team on board with that.
Yeah, not to have two separate team.
No,
like you said, one work on Vue 2 and the other one maintains the Vue 1. Yeah, you need to work together. Yeah.
The refactoring at scales. So like there was this. It's actually the title of a book by Maud Lemaire, who worked at Slack. And she was really into, so Slack, you can imagine a huge code base, a lot of clients. You cannot just disrupt everything, but you still need to refactor it because some decisions that made sense at the beginning don't make sense or are preventing important features. But how do you do that at scale? And yeah, the idea is that a lot of monitoring, by the way, I haven't mentioned it, but everything you do monitor what you're doing. Again, you want feedback. You want to know if you're going in the right direction, yes or no. And tests are just another tool to have fast feedback. It's faster to get a feedback by an automated test than having to figure it out manually, or someone, a user, report a bug. A test is here for that. And before even the test, depending on languages you're doing, but if you have a statically typed language, for example, if you're going with TypeScript, that's what I'm doing this day, a lot of things can be also captured in the type system, and that will be a feedback. Basically, you don't have. There are some tests you don't have to write because you model them, and the code will just not compile if you don't. If you have impossible states, for instance.
Yeah, but it's more than just have a feedback. I think I like your definition of legacy code. It's a code that you're afraid or fear to touch it. So I think this kind of techniques permit to not be afraid of go to legacy code and have a maybe a test harness to be able to refactor as we want. So it's really interesting.
Yeah, the definition I really like of the legacy code. The most common definition is code without test, which is true for most code that is not tested. But I've also seen code that was tested, but the tests were hard to maintain. So you could define that. The definition I prefer is actually, it's valuable code that you're afraid to change. Valuable because we're talking about code that is used in production. You cannot just throw away. It's also probably, if you're working for a company, it has been successful. You got this job. It's paying your salary, and so we tend to disregard a lot of like, this is stupid, it's too overly complex, etc. And probably true, but maybe it made sense at the time it was written, and you've lost the context, and today it's still working and providing value to people. But you're afraid to change it for many reasons. And yes, TDD, refactoring techniques, approval testing, we mentioned, all of these tools are here to help you reduce the risk, be less afraid, be less stressed about it.
And permit to improve the design of an existing code. Yeah. So it's you have summarized all the benefits of trying to tackle legacy code with test. Yeah. And the specific part of TDD can help to implement new design and try to have an emerging design, yeah, in order to add some pattern in existing code that is valuable. That you have seen, you said that your business make money with this code, so we need to improve it. Yeah.
The goal, and even the goal of TDD, it's not to slow everything down. Actually, it's a difficult debate because it depends also on how people are familiar with writing tests. For example, just that, like someone who never writes tests, writing tests will take them a lot of time. Now, if that's something you're used to do, expressing yourself with a test will be natural for you, just like writing code. Also, we haven't talked about it, but AI tools can help you do a lot of these, also support you in doing them, not do them for you. Well, be careful of them doing it for you, because if you don't understand what is being produced, it's not going to be helpful as you think it is.
I think artificial intelligence is code generate that we don't understand it, and each new code generated by the artificial intelligence introduce some new bugs, so we need to avoid maybe to generate this kind of code.
It's I've these days, of course, for the past year and a half, I've been working a lot with how can AI help you work with legacy code, and there are things it can do for you. It can assist you in the work, but it cannot do the work for you. you know, to give a concrete example on a different domain, but it's like having the computer generate mind maps for you. I've seen that. Like AI can generate a mind map for you out of a video, YouTube video, 25 minutes video. And the artifact looks cool, but the artifact of watching the video was not really the mind map. The mind map is not that useful if you haven't built it. I don't know if you try to just read a mind map from someone else, it won't be as useful as your own mind map. You do a mind map so you can retrieve when you want to go back to that information and remember what it was about. You have encoded how your brain works with relations, and you can quickly go and be like, oh yeah, I remember, with a few keywords or a drawing or something. You're like, I remember this, and everything connected.
Yeah.
But I give you my mind map, you will be like, ah, interesting. But if you don't have the content, you won't find it on the mind map. So using AI to produce the artifact for you is not as helpful as you think. Using AI as a support, like, okay, I have this code. Can you find me the different inputs I could provide for my approval test? And it can suggest things because it will read the code better than you. It may have more context. It will go faster than you. And you can interact with it as an assistant. Like, this is what I want to do. And you're going to help me do that faster because you can process code and things faster than I can do. And I can ask you a question. And with this interaction, you will make me faster in understanding what the code is doing.
Okay, but to talk about the team, I think, like you said, we need to work together because we need to write test or code not brittle. You need to foster sociable programming in order to have a sociable test and not a solitary test, for example. So it depends on the team, like you said, to introduce this kind of practice, but we need to foster sociable programming and the teams, by sharing some practice and be together and avoid some pull request technique or things like that, to avoid to work in isolation, like we have said before. So we have the podcast is it's maybe the duration is 1 hour. So we will, if you have a conclusion about this focus on TDD and the legacy code, what is your conclusion?
Actually, I would like to open a door to another topic as a conclusion for people to think about. But we talked about a lot of things you can do, and there are a lot of doors to explore. I think it can be. I would recommend people to try and practice and view TDD as how can you use it to design code, but you express yourself in a test, and so the test is an artifact, but you use TDD to think about what you're gonna do next, one step at a time, and this is really what TDD is about. And to open the door and bouncing on what you said, working with the team, I think that's the most difficult part actually of building software. We talked about legacy code and how it's hard and how we have techniques and stuff, but there is a legacy culture that is the one thing that will take the most time to change. But if you are motivated, there are things you can do. Have your coworkers be interested in solving the problems you have and change the way you work.
By the demonstration, maybe. I think
leading by example.
Yeah, leading by example.
Practicing coding katas together, sharing resources, videos, ideas, discussing. You cannot be perfect. Also, like, there are a lot of theories and things that look clean in trainings and in articles, but the reality of your code base will be different, and that's fine. The question is not how can you have this architecture in your code, but how can you maybe move towards this architecture, at least in the core part of the code, to make it easy. The goal is it's easier to change code. You can change it without having regressions, fast, and be done about it.
I like to couple it to the mental or psychological health or psychological safety, all this kind of non-toxic environment, I think it's better to convince other people by tell us that with this kind of practice we can improve your psychological safety as well, and your mental health also, and reduce your daily stress too. So thank you, Nicolas. I am in a continuous improvement approach. So if you have some suggestion or feedback, don't hesitate to leave your comments on the Q&A section. Don't hesitate to join our LinkedIn page or YouTube channel. And if you have question, we'll try to answer it with Nicolas. So thank you so much. Bye. And for our podcast listener, I can't wait to see you in the next podcast. Bye.